Hey everyone, welcome to the first coding video on core type. So today we're going to be talking about numbers. I'm sure all of you guys when you're little probably learned about numbers like, simple numbers like 0, 1, 2, 3, 4, 5. But then as you started to get older, you started to learn negative numbers like -1, -2, -3, -4, and so on. Then maybe we started to go a little bit more advanced and started learning about decimal numbers, like numbers between whole numbers, things like 1.2, 4.5, 6.34. And then after that, I'm sure of you in late middle school or high school, you started learning about even more advanced numbers like e, pi, and the square root of 2. These numbers are known to not have an ending. These decimals go on forever. Um, so all of these are called numbers, okay? So numbers can include whole numbers, decimal numbers, and these complex irrational numbers. But in terms of Python, we group them into two distinct categories. We group them into integers and floats. So first, let's talk about integers. An integer is a number that returns a remainder of 0 when it's divided by 1, or in other words, it doesn't have any fractional parts. Examples of integers are numbers like -2, -1, 0, 1, 2, 123, etc. So we provided this definition that it returns a remainder of 0 and divided by 1 because whenever we divide a number by 1, we always factor in for the whole number. If there's anything left over, or in this case, that's a remainder, that's an indicator that this is not an integer. So those are integers. Now let's move on to the second type of number, a float, or as we call it, a decimal number in high school. In Python, we call it floats because regardless of whether or not it can be simplified, these are all numbers that use a decimal point. Examples of floats are 1.2, 4.5, 6.34, and then irrational numbers like pi, e, square root of 2, etc. But there is one caution when dealing with floats. Like I just said, floats are a little bit different than decimal numbers in high school because even if they're simplified, numbers like 5.0, 6.0, -1.0, and 7.0, which all can be simplified to 5, 6, -1, and 7 respectively, even though they can be simplified, they're not considered integers. They're still considered floats solely because they have a decimal point. And some of you might be wondering, why would Python do it like that? Why would they want a number like 5.0 to be a floating point number instead of an integer? But this is because of the way Python wants to allocate its data. So if you're in Python shoes, let's think about it for a second. An integer is a number that only consists of the digits before the decimal point. So numbers like 123 only have to store the memories of the 123. But then if we include a floating point number like 123.25, then we start to realize that a floating point number is really just an integer plus some more digits. And because floating point numbers have these more digits, Python needs to allocate more memory to store floating point numbers than integers. Okay, so when we store floating point numbers, because they're integers plus a little bit of decimal after, we start to explore something in Python called data types. So numbers is not a data type. Numbers is just something I like to use in order to branch into two separate data types. The data types we're talking about here are integers and floats. So you might be wondering, what exactly is a data type? In Python, there are multiple data types, and a data type is basically a mode or a type of way that Python decides to allocate memory or data to a specific number or string or float. A data type is all dependent on how Python wants to allocate memory to it. That might be a little bit complicated for you if you're not familiar with things like memory and things like that, but all you really need to know is that there's two types of numbers, integers and floats take up more memory than integers. All right, so now that we've talked about theory, let's start to get into the actual code, okay? So if you don't know, this is how I like to do my lessons. I like to list a bunch of questions in order that we're going to go through, and then we're going to, it's just so that whenever we can organize the lesson, and once we go through, you can see the question that I asked and how I used code to answer it. So it's a pretty neat process for you guys to know. what exactly I'm talking about and then see my response to it. All right, so first, the first question is, how can I create a number? So in Python, this is really simple. It doesn't have to do any, you don't have to do any special actions or typing. All you have to do to create a number is type a 5. A 5 is a number, okay, a 5. That's a number. 6.7 is a number. 123.567, that's also a number. So these are all numbers, okay? Um, you don't Yeah, this is just a number. We're not doing anything with it yet. I'm just telling you how you can create it. So it's nothing different than writing a number on a piece of paper. All you have to do is type the number, or if it's a decimal number, type the numbers with a decimal point, and that's how you create a number. Um, Before we continue, some of you might be wondering what this hashtag is up here and then this piece of text. So I have that all throughout my page. These are basically called comments, and I'll go into that in more depth in another video. But for now, all you need to know is that whenever Python looks at a cell and runs it, it completely ignores anything that comes on the line after the hashtag. So Python is going to ignore this whole line and it's only going to focus on this. You might be able to see that when you see like this is all gray, and maybe if I type a number 5 here, you can see it's also gray. So it's pretty dark gray, and everything that's color is all ignored. So none of this code or text type over here is ever going to run. It's only going to run the stuff I put under it. So I'm not going to run this box because all I showed you was how to create a number. But now we're going to talk about something else, okay? We're going to start to actually get into coding. So the next question is, what is the print function? So the print function really doesn't have much to do with numbers, but it's something we're going to use throughout the course in order to get used to coding on a .py file when you start to get to that. So first of all, you might be wondering what a function is, but you don't need to know what a function is yet. We're going to go into great depth in that later in the course. However, for now, the print function is just a basic concept in Python. The print function is a function that allows us to print something to the console. Right now, we're using a Jupyter notebook, so the print function won't really seem that important. But when we start to code in .py files, the print function allows us to print information we need to see during the code and on the command line so we can see it. For example, let me type it right over here. If we just type in a simple 5 and click Shift Enter to run the cell, you can see it outputs a 5 right over here, okay? Um, in the Jupyter Notebook, you really won't see any difference, but what we want to start getting used to instead of just typing a 5 here is to type print 5, all right? So you might have seen that it didn't even change at all, but this is important, this print notation right here, because when we're coding in a .py file, we don't have cells like these to just run individually and see output. So if we just include a regular 5 in a .py file, although we're seeing it run over here, in the actual file, you won't see any output whenever you run it in the command line or in some type of a IDE, you won't see any output if you just type a 5 like this. If you want to see it once you run the code, you need to type print 5. Again, you might be confused what notation this is, but we'll go into functions in greater depth in another video. So that's the basics of the print function. It allows us to put whatever we want within the parenthesis, and it'll print it in the line or the output part of the cell below. All right, so that's just some basic stuff you need to know before we move on. So now we can see how do we check the data type of a number? So as I mentioned before, the two data types in this video that are pertinent to numbers are floats and integers. Um, as I said before, examples are like 5 is a float and 6.7 is an integer. But how exactly do we know that 5 is an integer and 6.7 is a float? I might have just said 6.7 is an integer, I meant 6.7 is a float. So to do that, we want to use another function called type. All right, so this is not something we're going to be using a lot, but this is just for us to see what exactly the data types we're dealing with. So if we type 5, you see we're going to get an integer. And this is because if you look closely, 5 we describe as an integer, right? So we know 5 is an integer, I told you guys before. So when we type type function, what this is basically asking is, return the data type of whatever is in between these parentheses. So we know that's 5, we typed in 5. So what is the data type of 5? We know that's an integer, so what did it return? It returned integer. On the other hand, if we type in a float like 6.7, it'll say float 6.7. And then remember how I said before that Python allocates anything with a decimal point to be a float, even if it can technically be simplified to a whole number. We can confirm that by again running this out, and we'll get float again. So that's just some basic things we can do in order to check what data types we're dealing with and make sure that we're dealing with, make sure we know the difference between floats and integers using the type function. Again, we'll go into more depth in functions later throughout this course. Okay, so the next question is, what are some operations we can do with numbers? And a simple answer to that is that I'm going to put a comment here because you won't be running any code in this line, but it has to do with PEMDAS, okay? Oh, PEMDAS. So if you don't know what PEMDAS is, it's a way that children remember the order of operations, and it goes parenthesis, exponents, multiplication, division, addition, subtraction. So we're going to be going through how to do each of these in Python, and we're gonna explore them right now. So first we have addition. So addition is really simple. Remember, like I said, we're going to be getting in the habit of putting everything that we want to output within a print function, okay? I'll talk about what that means later, but right now we're just going to put it in the print function. So for example, addition, all we have to do is type a plus. So we have right here 5 plus 5, right? If we run the cell, we get 10, all right? So now if we want subtraction, we can do 5 minus 5. And then we get 0. So you might be wondering why 10 and 0 run. It's because we already have this code over here, and then this line ran. So we have 2 lines running in this cell, which gave us 2 outputs. So we have a print 5 plus 5, it's 10. A print 5 minus 5, it's 0. So it's pretty simple so far. We probably use the plus and minus sign to kind of simulate math on text we use or things like that. So multiplication, you might think maybe 5x5 looks like multiplication, but we actually use 5 asterisk 5. So you'll see we get 25. So the asterisk is shift 8 on your keyboard. It's the asterisk shift 8. We use the asterisk because actually it's used a lot in other languages to use multiplication, and the asterisk is kind of a step in for multiplication, so we use the asterisk. Lastly, we can do division, things like 5 divided by 5. So you'll see that we get 1.0. So one thing I would like you to realize here is we used integers for all of these, right? 5 is an integer. We already looked at that up here before. So we know 5 is an integer. So when we add 5 and 5, we return a 10. We return an integer. If we do 5 minus 5, we return another integer. If we do 5 times 5, we return another integer. But when we come to division and we divide an integer by another integer, unlike the previous ones, we will always return a float. So one thing you need to remember in Python is that every time you do a division, it will always return a floating point number. All right? So we've done everything with integers, and now I want to go through and do it with decimal point numbers. So maybe we can do things like 1.2 plus 3.5. All right, so we're just going to be looking at the first output here. We know 1.2 plus 3.5, if we add it properly, we're going to get 4.7, right? So now let's do this one. Maybe we can do 1.2 minus 3.5, right? So we get a negative 2.3. So this was just to show you that Python does indeed can deal with negative numbers, and even more important, negative floats, right? We can deal with all of those. Next, we're going to do maybe 1.2 times 2.5. So 1.2 times 3.5, we're going to get 4.2 because that is the product of 1.2 and 3.5. And then lastly, we can do things like maybe we can use whole numbers. We can use 19 divided by 5. Those are still integers, and we're going to return a floating point number. We can also use decimals themselves. We can do like 1.9 divided by 6.7. We're going to get a really long answer here because that's not really able to be simplified. It's irrational. So Python stores as much memory as possible and then cuts it off so that because we don't really think about ourselves using all of the values over here to make computation, so it'll just cut off after a while because that's all the memory it can store. So you can see here we did 1.9 divided by 6.7, and we used floating point numbers for all of these basic operations, and you can see they worked. So one thing we can tell or pull from this is that operations also work with floating point numbers and integers, so it's compatible with both. Let me just erase this line here and go back with 19 divided by 5, because 19 divided by 5 is something we're going to be using for another 3 questions or something like that. So just so you know which one is exactly 19.5, I'm going to negate all these lines just so that we get a 19.5 back. So as I said, we're going to talk about more about commenting in another video, but all I basically did was make sure that these lines don't run anymore, right? So we just have print 19 divided by 5, and we get a floating point number. So now a question that people tend to ask is, maybe we don't want to deal a lot with decimals. Maybe we're dealing with discrete objects. So then we have to ask, how can we round our division to an integer, right? How can we round our quotients? That's an important thing we need to discuss. So in Python, there's something specifically called floor division, right? So a floor division, instead of doing something like this, which we just did above, floor division involves using 2 slashes. So we use 2 slashes here. So what exactly did that do? Let's look at the difference between these two. When we printed 19 divided by 5, we get 3.8, right? But when we print 19 floor divides 5, we got a 3. So all this is basically doing is rounding down this floating point number to the greatest integer that's less than it. So the greatest integer that's less than 3.8 is 3. So all it's doing basically is rounding down the quotient to the nearest integer. In fact, this actually returns an integer, okay? So this 3 over here is not a floating point number, it's an integer, and obviously we can even see that because it doesn't have a decimal point. So this will always return an integer if we use 2 slashes and floor divides. So that's rounding down, but maybe some of you might want to know how we can round up. There isn't really a built-in function for that, but one thing that always works is just adding 1 to our answer, okay? So we just did 19 floor divides 5, and that gets us 3, right? If we want to round 3.8 up to 4. So all we have to do is do 19 floor divides 5 and round it up to 4. You might also be wondering, what if we don't want to choose whether we want to round it down or round it up, and it follows basic rounding rules. Basic rounding rules are things like if the last digit of the number is 5 or greater, round it up. If it's less than 5, round it down. We're going to be talking about that later in the course. There's specific methods that allow us to do that. But for now, we're going to have to deal with things like this, where we have to choose whether we want to make this addition and round it up, or remove it and round it down. All right, so that's how we can round our division to an integer in Python. So now the next question you might be asking is, so using this, we got the whole number of our quotient, right? We got 3, right? But what if we want to get remainders from our division, right? What if we want to get the remainders from our divisions? Like, this is 19 divided by 5, and we got 3.8, right? But what if we want to get the remainder of 19 divided by 5? So to do that, we have another special symbol, I should say, which is the mod sign. We call it a mod sign. For those of you who are new, this is just a percent. A percent on your keyboard is shift 5, so that's just the percent sign. So let's analyze this here. So we printed 19 mod 5, and we got a 4 returned. So why is that? Let's think about what the remainder is when we divide 19 by 5. So how many times does 5 go into 19? It goes, let's see, if we multiply 5 times 1, we get 5. 5 times 2, we get 10. 5 times 3, we get 15. If we multiply 5 times 4, it goes over 19, so that's too much. We only can do 5 3 times into 19. And we didn't even have to do what I just did there. We just did it here, right? We did 19 floor divides 5, and we returned a 3. So there's only 3 5s that can go into 19. So then if we think about finding the remainder, if we do 3 times 5, we get 15, right? That's the maximum number of 5s you can put into 19. So we have 15, but we wanted to get to 19. So what remains? Well, we do 19 minus 15, and we get 4. So using the mod sign, we can get remainders in Python. Another example maybe is if you maybe want to do 20 divided by 5. So 20 divided by 5 is what? Well, think about it. Uh, 5 goes evenly into 20, right? 5 goes into 24 times. So there shouldn't be a remainder, right? The remainder should be 0. Let's see, let's run this out. And indeed, we get 0 because 20 is a multiple of 5, and we wouldn't get any remainder because that's how multiplication properties work. So we just demonstrated these two cells using only integers, but we can also use floating point numbers to do that. For example, we can do 2.5 floor divides 0.4. So let's think about what this would return, all right? So what is 2.5 divided by 0.4, right? So if you want to do that in your head or a little bit, 0.4 times 6 is 2.4, right? So 0.4 times 6 is 2.4. If we do 0.4 times 7, that gets us to 2.8, and that's above 2.5. So if we're trying to do a floor division, it can only return a 6. Now, you might be wondering why it didn't return an integer like I said it would. Well, when we use floating point numbers in operations and arithmetic like this, if we even have one floating point number, Python will automatically allocate extra memory because it doesn't want you to lose memory, right? Python would rather use extra memory to store any floating point information you have rather than store it as an integer and lose any of that information, right? So no matter what, if there's even one floating point number in your operation, Python will store it in a floating point number, right? That's the only difference when we're using when we're using integers and floats. But you can still see here, it did round it down to the nearest integer because in our brains, 6.0 is the same thing as 6, right? So it did its job. It rounded it down to 6. So now we can round it up. Like I said, simply we can just add 1 and we'll get 7.0. So now we can do the same thing with floats. Let's think about doing 2.5 not floor divides, mod 0.4. So like we just got our result, let me delete this +1 over here. So we got 6, right? So if zero point 0.4 goes into 0.256 times, that's 2.4. So to get the remainder, we have to do 2.5 minus 2.4. So our answer should be 0.1. And you might be wondering, oh man, we didn't get 0.1. But let's look at it a little bit more carefully. If you really try to understand what this long decimal representation is trying to tell us, you can see clearly that this is approaching 0.1, right? With all these nines, 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 nines. All it's trying to do is it's trying to approach 0.1. And you might be wondering, well, then if it's 0.1, why didn't it print 0.1? Well, that's because the way Python does this division, it's kind of difficult for the way Python does a division, they have to do repeated subtraction, okay? Like we do. When we do long division, we do repeated subtraction. So when we're doing repeated subtraction, we're going to get to a point where we keep adding and adding decimals until it reaches the max, right? Like we do in long division. So it's just going to return that, but it's up to us to understand that this is 0.1, but Python returned it this way because it uses long division. In fact, if we go up here and use the same example we just used to prove decimals can work with floor division and mods, if we do 2.5 divided by 0.4, we're going to get 6.25. So this doesn't have to deal with the issue of trying to find a remainder, because if we're trying to do long division here, you might think that we could just simplify this to 25 divided by 4, and that would return a simple decimal. But here, when we're doing floor division, when we're trying to find a remainder, it becomes more difficult for Python to do that repeated subtraction. All right, so that's how we can get remainders using the mod symbol, and we can get rounding using the floor divides. So now let's move on from division and talk about exponentiation and parentheses. So for those of you who don't understand what exponentiation is, it's just repeated multiplication. So you might understand how multiplication is repeated addition, exponentiation is just repeated multiplication. So ways we can do that is, let's say we want to print 5 squared, right? So to do that, we can do it one way. We can just print 5 times 5. But if we want to print 5 squared, we can do 5 double asterisk 5. Remember the asterisk to shift 8. If we do 2 of them, it turns into an exponent. So basically this is 5 squared. We can return 5 cubed to be 125. We can return 2 to the power of 7. So you can see here that we're doing exponentiation. We can do the same thing with decimals. So if you look, we can do a way we can use decimals in exponentiation is if we're trying to do something like the square root of 25. So you might be thinking, this doesn't really look like the square root of 25. Or maybe if you're a little bit more advanced, you understand that this is the square root of 25. But if you don't, this is basically 25 to the power of 1/2, right? So when we do square roots, when we take a square root of a number, it's the same thing as raising it to the power of 1/2. So it's exactly what we're doing here. So if we take the square root of 25, we should get 5 returned. But you can see here, like I said before, this becomes a floating point number because we included a floating point number in our operation, right? Okay, so now we can use parentheses. This is the last part of PEMDAS, okay? So let's look at a basic example of parentheses. We can do something like 6 plus 6, 6 times 5. Let me put that all in the print. And let me, in fact, divide this into 2. So, okay, so this is our exponents. So I'm going to look at parentheses. If we print 6 plus 6 times 5, we put parentheses around the 6 times 5, right? So it'll calculate whatever is in that first. So we know 6 times 5 is 30. And we have 30 here, so we add it to 6. So it should print 36, right? Now let's look at the parenthesis, the power of parenthesis to do things that aren't that apparently obvious, right? So we might know that, we don't really need parentheses here because 6.5 is technically before addition, so this should calculate anyway. So let's go see what happens if we put parentheses around the 6.6, the 6 plus 6. So now that because the parentheses are in front of the 6 plus 6, we have to do that first. So 6 plus 6 is 12. And then if we multiply that by 5, we should get 60, and we do. All right, so that's basic parentheses and exponentiation. It's not too complicated. But now let's ask the question, does Python follow order of operations? Python does follow order of operations, okay? So we can do that by analyzing what we just did up here, right? So we had parentheses on both parts of the problems, right? And I just told you that if Python follows order of operations, we don't really need parentheses around this part, right? So to confirm that, let's see what happens if we don't put parentheses and follow order of operations. So if there's no parentheses or exponentiation, so now we move on to multiplication, the M in PEMDAS. So do multiplication first, 6 times 5 is 30, and then we're going to move on to addition. So 30 plus 6 is 36. And indeed we get 36. So this proves that Python follows the order of operations. Something a little more difficult you might want to try is doing something like 3 plus 6 times 4 to the power of 1 divided by 3. So this is a little bit complicated maybe, but let's look at it, right? So first in PEMDAS is parentheses. So let's look at all the parentheses stuff first, right? So this is a parenthesis. There's not really anything we can do to simplify here. This is just 1/3. Let's look at it here. So we're going to go in this parentheses first. Now we're going to move on to multiplication in this parenthesis. So when we go into a parentheses, we follow through the order of operations, and then we look at the bigger picture. So now that we're in this parenthesis, let's look at multiplication. 6 times 4 is 24, right? That's multiplication. And now we're going to do addition. So 24 plus 3 is 27. So whatever is in this parenthesis right over here is 27. And now we have to go back to the beginning of PEMDAS and go to exponentiation, right? So this is 27 exponent to 1/3. So if you don't know, when we raise something to the power of 1/3, we're essentially doing a cube root on it, right? A cube root is whatever number is cubed in order to get the number you're trying to find. So we have 27 to the power of 1/3, or the cube root of 27, and that should get us 3. And you might be wondering why we got a 3.0 here. I don't see any floating point numbers in our operation. But that's because, like I said, whenever we do division, it always returns a floating point number. And because of that, this becomes a floating point number, and now we're doing floating point numbers in exponentiation, like we did up here, so it's going to return a floating point number. So to answer this question, yes, Python does follow order of operations. Next, we're going to talk about the question, can we do arithmetic with both integers and floats at the same time? Let's answer that. All we have to do is test it out, right? So let's look at things like 7 plus, let me put it in a print. Print 7 plus 3.5. So that gets us 10.5. So first of all, we can say, yes, we can do arithmetic with both integers and floats at the same time. And second of all, like I said before, when we use a floating point number in our operations, Python will return a floating point number no matter what. So now we can do things like 7 minus 3.5, that still works. 7 times 2.5, that works. 7 divided by 3.5, that works. 7 floor divides 2.5, that works. 7 mod 3.5, that works. 7 to the power 3.5, that works. So we basically just went through all of our order of operations using, or not our order of operations, all of our regular operations using one integer and one float. So yes, this is true. All right, so this is kind of the point where I like to let you guys do something for yourself. All this exercise is made up of 2 parts, and this is the prompt you're going to want to answer, right? So pause the video and try and see if you can do this. So I'll read it out for you. So print the area and the perimeter of a rectangle with 5 units length and 7 units width. And then print the area and perimeter of a square with side length of 9.3 units. All right, so pause the video now, do that, and then come back when you're done. Okay, so I'm assuming you paused the video and did it, so now let's look at it. So we want to print the area and perimeter of a rectangle with 5 units length and 7 units width. So if we don't know, the formula for a rectangle is length times width. So to print the area, that's pretty easy. We just do print 5 times 7. So that solves the area part, right? Because area of a rectangle is length times width. We were given 5 and 7. So now let's print the perimeter. The formula for perimeter of a rectangle is 2 times the length plus width. So we have 2 times the length and the width. So if we run that, we should get a 24. So the area of a rectangle with 5 units length and 7 units width is 35, and the perimeter of that same rectangle would be 24. So now let's look at the area and perimeter of a square with side length 9.3 units. So to do that, let's think about what the formula for the area of a square is. The formula for the area of the square is just s squared. So if we take 9.3 and square it, that will give us the area of the square. This might seem like a really long decimal, but again, if we use our brains to understand what it's trying to tell us, this 0.0000001 is basically just 0, so the answer would be just 86.49. All right, so now let's print the perimeter of a square with side length 9.3. If we think about the formula for a perimeter of a square, it's just 4 times the side length. So if we just want to do that, we do 4 times 9.3, and we're going to get 37.2. All right, so that's the solutions to the exercise. We just calculated the area and perimeter of this rectangle and the area and perimeter of this square.